Hello, welcome back to my YouTube channel. In today's video, we're going to be looking at special right triangles. Let's jump right into it. So in geometry, there is something called a special right triangle, and there are two versions of this. There is one triangle which is 90 degrees, 45, and 45 degrees, and the other is 90, 30, and 60. And the special thing about these triangles is that their sides have special relationships with each other, which is helpful to us because we're able to find the lengths of their sides quickly and efficiently. So let's go ahead and take a look at these different relationships. So the first one is for a 45-45 triangle. This special right triangle tells us that if we know that the length of one leg is x, and we know that both of these legs are equivalent to each other because both base angles are equivalent to each other. So it says that if we know that both of these sides are x, we can say that the hypotenuse is going to be equivalent to x times the square root of 2. So for instance, if we knew that x equals 3, we would be able to say that this side over here is 3, this side is 3, and the hypotenuse is going to equal 3 times the square root of 2. So this is the other special right triangle. This one is often referred to as the 30, 60, 90 triangle because it is made up of an angle with 30 degrees, 60, and 90. So the relationship between the sides in this triangle are slightly different. In the 30, 60, 90 triangle, everything is based off of the short leg. And remember, the short leg is going to be opposite the smallest angle, which is going to be 30. So our short leg is going to be x. Now our longer leg is going to be opposite the larger angle, which is 60. And our longer leg is going to be equal to x times the square root of 3. Our hypotenuse, which is opposite the right angle always, is going to be equal to 2x. So by looking at this, you can see that basically once you know what x is, you can solve for any part of this triangle. For instance, if, like in the previous problem, x equals 3, we would be able to say that this side over here is 3, this side over here is 3 times the square root of 3, and this side over here is 2 times 3, which is 6. So just like that, we have solved for all parts of these triangles. Let's go ahead and get a little more practice with this. All right, so we have this table here and a 45-45 triangle. And the instructions tell us to fill out the remaining parts of the table. So just as a reminder, I'm going to go ahead and write down the formula in a different color next to each side, just so you'll have a refresher. So remember that in a 45-45, if this side is x and this side is also x, then the hypotenuse is going to be x times the square root of 2. So knowing that information, let's go ahead and fill out our table. So we know that a is x, and since a is x, we can also say that b is x as well. So b is going to equal 4, and then c is going to be x times the square root of 2, which we know is 4 times the square root of 2. All right, next one. So we know that b equals 4 times the square root of 2. And since b equals 4 times the square root of 2, and we know that a and b are always equal, we can say that a is also 4 times the square root of 2. And then we need to find c. So we know that our x is 4 times the square root of 2. And 4 times the square root of 2 times the square root of 2 is going to equal, well, if we just look at the square roots, we can see that the square root of 2 times the square root of 2 is the square root of 4, and the square root of 4 is 2. So these two equal 2. So then we can go ahead and say that 4 times 2 equals 8, and therefore c is going to equal 8. Alrighty, and now we have one more column left. So this one we are told that c equals 6. So that means that 6 equals x times the square root of 2. So in order to get x alone, we're going to first divide both sides by the square root of 2. So we're going to have 6 divided by the square root of 2 is going to equal x. However, we can't have a square root on the denominator of a fraction, so we need to rationalize it. So 6 times the square root of 2. Alrighty, and then this is going to equal a 2 on the bottom, and then 6 times the square root of 2 on the top. However, we're not done yet. This can still be simplified. So 6 and 2 can be simplified to 3 over 1. So our final answer for x is going to be 3 times the square root of 2. So we can fill this in for both of our A and our B column. And of course, if you ever want to check, you can go ahead and just do 3 times the square root of 2 times the square root of 2. And we know that these two square roots of 2 are going to equal 2, and 3 times 2 is 6, which is exactly what we got. So now we've went ahead and we filled out this entire table for the 45-45 triangle. Alright, so now we're going to go ahead and fill out this table again, but this time the table is going to be for a 30-60-90 triangle. So I'm going to label this side as A, B, and C. And now I'm just going to go ahead and remind you of the formulas for this triangle and the relationships between the sides. So A, which is our shortest side, is going to be x. This one is x times the square root of 3, and this one is 2x. So let's go ahead and fill out our table now. So for the first column, we can see that 7 is equal to x. So if we replace 7 wherever x is, we're going to find out the other two unknown values. So if we replace it for the B length, we will get 7 times the square root of 3. And if we replace it over here for the C length, we're going to get 14 because 7 times 2 equals 14. So now we are told what the B length is for the next column. So the first thing we need to do is find out what the x value is, because everything in this triangle is based off of the short side. So we know that x times 3 is going to equal 5 times the square root of 3. So since we're multiplying, we can simplify and get rid of the square root of 3 on both sides, and we're left that x equals 5. So we can replace our unknown value here with 5, and then for our C length, 5 times 2 equals 10. So that is that value. Now, finally, for the last column, we know that 2x equals 13 because 13 is our C value, and our C value length is 2x in this triangle. So if we divide both sides by 2, we're going to get that x equals 6.5. So we can replace that for our A value. And then we can just go ahead and input our x value into the equation for the B side of the triangle. So if we replace 6.5 in this formula, we're going to get 6.5 times the square root of 3. Alright, so now we're going to go ahead and use the information that we learned earlier in this video to solve for the lengths of x and y. So let's go ahead and get started. In this triangle over here on the right, the smaller right triangle, we can see that since this angle over here is 30, then this angle over here is going to be 60, and this one, of course, is 90. So in the 30, 60, 90 triangle, we learned that the hypotenuse, which is 8, is equivalent to 2x. So if we take 8 divided by 2, it's going to equal 4. So we know that our x value is going to equal 4. So now let's look at the smaller triangle on the left. So we can see that in this triangle, this side right here is actually across from the 60 degrees. So in this triangle, we can say that x times the square root of 3 is going to equal 4 instead. Now, since this angle is 60, this one over here is going to be 30, which is going to make the opposite side, y, the smallest side in the triangle, which is equivalent to x in a 30-60 triangle. So all we need to do now is just solve for x. So the first thing we need to do is divide both sides by the square root of 3. So x is going to equal 4 divided by the square root of 3. But since we can't have a square root on the denominator, we're going to rationalize it. So to do this, we just multiply the square root of 3. And that is going to equal 3 on the bottom and 4 times the square root of 3 on the top. Since this is the most simplified that a fraction can be, 4 times square root of 3 over 3 is going to be our y value. So x is going to equal 4 and y is going to equal 4 times the square root of 3 over 3. Alright, let's go ahead and solve one last problem. So in this triangle, we're dealing with 45-45 triangles. And remember that in a 45-45 triangle, the side opposite the hypotenuse is equal to x times the square root of 2, and the side and the two legs of the triangle are equal to x. So since this side over here is 6, then this side over here is going to be 6 as well. And then since these two sides are 6 and our hypotenuse is x times the square root of 2, we can say that our hypotenuse is 6 times the square root of 2. So now if we look at this triangle, we can see that that highlighted leg and that one are equivalent to each other since it's a 45-45. So we know that this side over here is also 6 times the square root of 2. Now finally, all we need to do is find our y value. And in this big triangle right here, the y value is opposite the right angle up there, which is going to make the y value equal to x times the square root of 2. So now all we have to do is plug in our x. So our x is 6 times the square root of 2 times the square root of 2 is going to equal y. The square root of 2 times the square root of 2 is 2, and 6 times 2 is going to equal 12. So our y value is going to equal 12. Thank you guys so much for watching this video about special right triangles. I hope that you learned a lot. Please like this video and subscribe to my channel down below if you haven't already. Thanks again, and I'll see you in the next video.